Reading this question is fairly straightforward. We simply need to find all the resonance structures for the nitronium ion that obey the octet rule. So a quick plan. First, determine the number of valence electrons the ion has. Then, use those valence electrons to construct resonance structures that follow the octet rule. Finally, determine the formal charges to ensure that the overall charge is correct, and count the number of resonance structures. Now we can solve the question. For the nitronium ion, there are 2 oxygen atoms with 6 electrons each, 1 nitrogen atom with 5 electrons, and 1 positive charge, which means we have to subtract an electron. The total number of valence electrons in this case is 16. To draw a resonance structure, connect each oxygen atom to the nitrogen. That uses up 4 of the valence electrons. Then place the remaining 12 electrons so that each atom gets an octet. After all the valence electrons have been placed as lone pairs, the nitrogen atom still needs 4 more electrons to attain an octet, so both oxygen atoms must share a lone pair. Or, 1 oxygen atom must share 2 lone pairs. Don't forget, it could also be the other oxygen that shares its electrons, so that gives us a total of 3 resonance structures. Now calculate the formal charges on each atom. Remember, a line counts as 1 electron when you're determining formal charge. The 2 oxygen atoms that are doubly bound to nitrogen have 6 electrons each, so they're neutral. In each structure, nitrogen has 4 electrons, so it carries a positive charge. The oxygen atoms that are singly bound to nitrogen have 7 electrons, giving them a negative charge. And the oxygen atoms that are triply bound to nitrogen have 5 electrons and a positive charge. Finally, check your work. Make sure all the formal charges add up to the correct overall charge for the molecule, and check that each atom has an octet. And make sure you answered the question. There are 3 resonance structures. Note that the central structure has the least formal charges. It's by far the most important of the 3.